Okay, boys and girls, when you do this sprint, it's going to be easier than it looks. So what I want you to do, we'll just do a few of them to start with, and then we'll do a few on the other side. But I want you to take your highlighter and just highlight 3, 6, 9. Highlight those. Then over here, highlight the ones that have a 99 in the problem, and we'll practice a few of these also. Okay. The ones at the beginning are pretty simple. The ones toward the end get a little more confusing. Okay, so we're actually only doing part of these problems. The first two just help us with our thinking, okay? So for instance, if I'm going to do 5 times 99, what will I change the 99 to?
100.
100. And that will be 500, right?
Yeah.
And then to get the 99, I have to subtract 1 for each time I multiplied it. So that means I would subtract 5. So 495. We'll do a few of these. So the answer to 5 times 99 is 495. We're thinking 100 and then 100 minus 5. This is like lesson 4, I believe, where you had to figure out 29, we changed 29 to 30. And so we do like 30 12s minus 1 12. That's what we're doing here, only the numbers are larger. So to do 3 times 99, I'm going to think what?
100.
3 times 100. Then I'm going to subtract whatever this first factor is. So what was the first factor? 3. So it'll be 297. So the answer here is 297. You want to get the door for me, please? Okay, to do 2 times 99, I'm going to think 2 times 100 minus 2. Okay, now let's go across and do some more difficult ones. To do 24, we actually have to back up all the way to 21. So take a look at 21. It's 500. Then how does it change?
It goes to 50.
So 5,000. So to do 50 times 99, we're going to think 50 times 100, and that was 5,000. Now we subtract the first factor. What's the first factor?
50.
50. So 5,000 minus 50. Here's how I do it. I think in my head, 1,000 minus 50. What do I get? 950. 950. So I just change it to 4,950. We'll do a few of these so you can practice. Okay? So to do 80 times 99, we're going to think 80 times 100. So that is,
800.
good try, 8,000. Now what factor will we subtract from 8,000? I said the first factor.
The 80.
The 80. Okay, so I'm going to think 1,000 minus 80 is 920. So all I do is change that 8 to a 7 and write 920. Are you following me? So 60 times 100 is what we'll use to figure out 60 times 99. So it will be 6,000, and then we'll subtract what?
60.
60. So I'm going to think in my mind, it's easier to do it this way. 1,000 minus 60 is 940, right? Okay? So change this 6 to a 5. 5,940. How you doing? It's pretty confusing. Okay, let's do another one. Whoops. 11 times 11 times 99. We'll think 11 times 100. So 1,100. Okay. Then we'll take 1,100 minus 11. Now to do this, I would probably just think 100 minus 11 is 89. Okay. So it will be 1,089. 1,089. Okay. To do 21 times 99, I'm going to think 21 times 100. 2,100, right? Then I'll take it minus 21. So 100 minus 20 is 80, right? Minus one more.
79.
79. So it's going to be
2,079.
2,079. 2,079. Now I'm going to give you 4 minutes. You'll probably get quite a few finished. If you finish early, go back and double check, okay? And we will grade the ones we haven't done after the timer goes off. Okay, starting with number 10, 600, 594, 594, 400, 396, 700, 693, 900, 891, 800, 792. Okay, skipping over to 35. 3,100, 3,069, 7,100, 7,029, 4,200, 4,158, 5,247, 6,336, 7,425, 9,603. So we're just going to review one problem from Friday. And the reason we're going to review it is because there were some mistakes made. They're typical mistakes. Kids make them every year. I even sometimes make this same mistake. So we've got a quick fix for it, okay? So let's get this one set up. What number will I break apart?
12.
Okay. What will the 12 break apart into?
10 plus 2.
Okay. So that goes on the side. And 243 goes on the top. Then when I get ready to do my standard algorithm, 243 times 12, 243 will be on the top.
Yep.
Okay? Now, I want you to put your pencils down when you get that much done, because I'm going to make a mistake and I want you to see if you can figure out what mistake I make.
Okay.
Okay? And just raise your hand when you see it. Well, I haven't made it yet.
Oh.
I'm getting ready to, okay? Don't forget I'm recording.
Oh, no. Sorry.
Okay, so raise your hand or give me a thumbs up when you find the mistake. I'm going to give you a few more seconds here.
Oh, see you.
Okay, so how about Miguel? What mistake do you think I made? Now don't worry about me recording because I can just edit it out. Okay? So what mistake do you think I made?
The 4,860.
You're right. What did I accidentally do, Lexi?
You took the number on top and put a 0 at the end.
But so I took this answer, which is a partial product, and I multiplied it by 10. Guess what? That is such an easy mistake to make. So we're gonna figure out a strategy to help us not make that mistake.
Oh, you're supposed to do the top one.
That's right. So I'm just simply going to highlight the numbers on the outside of my area model. That's it. Okay? Highlight those numbers and you won't make that same mistake. So we're going to have 10 times 243. So there are the partial products.
I see
Okay.
why people get.
Yeah, it's very simple. I mean, it's a very easy mistake to make. It's made over and over again. So if we'll remember these, highlight those numbers. It's going to help, okay? So now, turtle head, if it helps you. 3 times 2,
6.
4 times 2,
8.
2 times 2.
4.
Is that a match?
Yes.
Okay, draw your arrow. You can draw a collar and write a 0, or you can think, I have to add a 0 when I multiply by 10, right? Okay, so 3, 4, 2. Is that a match?
Yes.
So does your answer match mine?
Yes.
Okay, so we're going to take that to the next level today. We'll add some more boxes and add some more numbers, okay? Let's do the application problem first. Okay. This is a good problem. So I'm going to read the problem and then I'm going to tell you a story and I'll pause it during the story. Scientists are creating material that may replace damaged cartilage in human joints. This hydrogel can stretch to 21 times its original length. If the strip of hydrogel measures 3.2 centimeters, what would its length be when stretched to capacity? Now here's what they're trying to get you to do. Think, oh, I don't know what capacity means. Oh, hydrogel, that's really hard. And what about cartilage? This problem's too hard for me, I can't do it. But what are we doing? It tells us right there what to do.
21 times.
21 times. So put a box around it. 21 times what?
It's originally.
Okay, what's its original length?
3.2.
3.2. So 21 times 3.2 centimeters. Now, what's the easiest way to deal with a decimal?
Oh, you can
Take it out. Take it out. Change it to unit form. Good job. Okay, so if I change 3.2, 3 and 2 tenths to unit form, what do I write? 32 what?
Centimeters.
No, I was looking for a place value.
Oh.
32 tenths. And can I take that times 21?
Yes.
Sure. Just don't forget when you're finished with it, you're going to need tenths beside your answer.
Okay.
So 2 times 1, 3 times 1. Anything times a multiple of 10?
A 0 to the end.
Good. 2 times 2,
4.
2 times 3. Okay, now I'm going to ask a question. So here's how we write it. Correct?
Yes.
Okay. And I want to remind you what our other strategy was. I mean, we know tenths place, don't we?
Yes.
But can we underline the digits to the right or past the decimal?
Yes.
So if I have one digit past the decimal, multiply times a whole number, my answer is going to have how many digits past the decimal?
3.
1.
1.
1. So tenths place shows my decimal where, George A?
In the middle of 2 and 7.
Okay, so 67 and 2/10 centimeters. Okay? How does this problem look different than the one we just did at the beginning of the lesson?
They're both they're both in the tenths place.
Well, true, but we had 2 digit by 2 digit. Thanks for raising your hand.
That there's 2 boxes.
There's more boxes on the area model, aren't there?
Yeah.
Yeah. So on the area model, we're going to break both numbers apart. Okay? Which what that will do is give us easier mental math problems. So stay with me. So this will be 60 plus what?
4.
And this will be 70
Plus
plus
three.
3. Now, Junior, you were gone, but this will help you do your lesson from Friday that you missed much simpler, okay? Yours are going to seem a lot easier than what we're doing today. So how do I know, boys and girls, and Junior needs to know this, okay? Which number goes on top of my area model?
73.
70. How do you know it's 73?
Because it's on the top.
Okay, stop. Raise your hands.
Because it's on the top of the
Standard algorithm?
standard.
Okay, so Cheney says it's because it's on the top of the standard algorithm, okay? Some of you said because it's larger. That's not correct. Here's what you have to do. To make your partial products match so we can draw those arrows, you have to keep what's on top, okay? So Cheney, you remembered correctly, 70 plus 3 goes on top. And then, whoops, 60 plus 4 goes on the bottom. And here's what you have to remember. I'm doing two problems here. I'm doing 73 times 4 and 73 times 60. So I'm doing 73 times 4 first inside that turtle head, aren't I? Then I'm doing 73 times 60. Which one's going to have a larger answer?
72 times 6.
The bottom, right? So closer to the bottom of your standard algorithm, the numbers are getting larger. That's how you have to remember that the 60 goes on the bottom here. Okay? So now, what did we add into our strategy today? The highlighting. So get the highlighters out and highlight those numbers. And then I want to walk you through these carefully so that the kids who are gone today can easily figure out what we're doing if they listen to the video. Right. I know. Okay. So I'm doing 4 times 7.
28.
28.
Oh my.
How many zeros?
1.
Okay. 4 times 3.
12.
6 times 7.
42. 42.
Give the others a chance to think, would you?
420.
How many zeros?
2. 1.
Okay. Think about the answers before you say them. I don't want to edit out the wrong answers. Spend my whole lunch break doing that, okay? All right. 6 times 3.
18.
How many zeros?
1.
Okay. Now here's what we do. You've got those in there. Now we have to add them together. The easiest way to add these together is just add them standard algorithm right inside that area model. You have room, so use that room. And then each partial product needs to be written right across from the numbers you added together. Okay? So 4,200 plus 180 I will add here. And then write it down. Now, to me, it's easier to just take this 292 and add it to 4,380 like that. It's easier to me to put the larger number on top when I add. Do you agree? So I like to rewrite it down here. On Zern, you might not see that. Okay, now we will do the standard algorithm. These partial products and this final product over here are not for us to just copy across. They're to help us in case we make a mistake over on the standard algorithm. Your focus needs to be up here. So you help me, tell me what the answers are. 4 times 3.
12.
So regroup the 1, write the 2. 4, I haven't even asked the question yet. 4 times 7
28.
plus 1.
29.
Okay, do we have a match? Okay, draw your arrow. Now, if it helps you, put a collar on the turtle and lay an egg, Or I like to think of anything times 60, add a 0 to the end, right? Okay, so 6 times, oops, what was Mrs. Judice's idea? You remember I told you last week?
Use X's and O's.
X's and O's, good memory. So there's an X, there's an O. Clever, huh? I know. 6 times 3,
18.
regroup the 1, write the 8. 6 times 7,
42.
plus 1.
43.
Now you have to be careful, line up your digits right on top of each other. Is that a match?
Yeah.
Okay, add them up. Okay, and you don't have to draw an arrow to the final product, okay? But that's us doing the math twice. We know we did it right, okay? Plus, we learned Friday this area model is going to be good for multiplying binomials, right? When you get older. But I don't expect you to know how to do that yet. Okay, so let's take a look at the next one. How is it different? Okay, so we've got 3 columns. That means we've got a 3-digit number we will break apart. Now I need some help here. You're going to have to go back to expanded form, probably 3rd grade. How do I write 814 for me in expanded form?
800 plus 10 plus 4.
Awesome. So that will go on top because what number's on top of my standard algorithm? 814. So 800 plus 10 plus 4. Now, you realize, don't you, those plus signs are optional. You don't have to write them there. You just have to know that you're going to add them up going across. Okay? And then 39, how will I break
30
it?
plus 30.
30 plus 9. Which one goes on top?
9. And 3.
Okay? Now get your highlighter. I'm going to talk you through this one again. So 9 times 8.
72.
How many zeros do I add?
2.
Okay. Notice how I left room to add underneath that?
Yeah.
That's a good idea. Because now we have to add 3 numbers. 9 times 10.
90.
And 9 times 4.
36.
Okay. Now 3 times 8.
24.
How many zeros?
3.
3. Good. And 30 times 10?
300.
300. Or you could do 3 times 1 and add 2 zeros.
Yeah.
Okay. And 30 times 4.
120.
So 3 times 4 is 12, add 1 0. Now this is the way I do it. And it makes pretty good sense. So add the first 2. Then take your answer to those 2 and write it on the last number. That's your partial product. Okay, now same strategy down here. Some of you might be able to add these mentally, but it's a good idea to know this strategy because we are going to do much larger problems in the future. Like 4-digit by 3-digit, okay? So there's not as much room for error if you do it this way. So 24,420 plus
7,326.
now add those up. So my 2 partial products I'm adding. Okay. Now on the standard algorithm, if you use a turtle head, please keep it close to your numbers because you're going to have regrouping at the top. Okay? So 4 times 9.
36.
So regroup the 3, write the 6. 9 times 1
9.
plus 3,
12.
regroup the 1, write the 2. And you have to be very careful, line up your digits. 9 times 8
72.
plus 1.
73.
Do we have a match?
Yes.
Okay, we're on the right track. So watch, this is Mrs. Judice's idea. X's and O's. But it's just one O, isn't it?
Yeah.
Okay. Or draw the collar, lay the egg. Okay, so now 3 times 4, what is it?
12.
So regroup the 1, write the 2. 3 times 1
3.
plus 1.
4.
Is there any regrouping there?
Mm-mm.
No. 8 times 3.
24.
Be careful, line up digits. Do we have a match?
Mm-hmm.
Yes. Oh.
Something happened.
Oops. I'm going to calibrate. Okay, now add them up. And does your final product match? Okay, we have one more to do. So take a look at the next one. Doesn't look much harder, does it? No? Okay, so how will I break 624 apart? Let's see. How about you, Emiliana?
600 plus 20 plus 1.
Good. And Junior, what about 82?
80 plus
Good. Which number goes on top, boys and girls?
The 2.
624?
Yeah.
And you meant the 2 on the top
Yeah.
row.
Yeah.
Okay. So 6 times 2,
12.
add 2 zeros. I'm not going to ask you on these. You do it, then look up at mine. What did I forget to do?
Highlight.
And I almost made a mistake because of it. I just about multiplied 8 times 4 on this one. Okay, now I want to point something out. There's really no reason to write the 8 underneath the 40, is there? So just write your 48 here. Oops. Okay, so far do we have the same answers?
Mm-hmm.
Yeah.
Okay. Okay. Okay, 4 times 2, 2 times 2,
4,
6 times 2.
12.
There are no x's at the top. You're going to have to remember your zeros somehow. Anything times 80, add a 0 to the end. 8 times 4,
32.
3 groups of 3, write the 2. See how my 2 is almost over too far? Got to be careful and line up my digits. 8 times 2,
16.
plus 3.
19.
So I got to squeeze that 9 right underneath the 2 so I can add them correctly. And 6 times 8,
48.
plus 1.
49.
Now look at your partial products. Do we have matches?
Mm-hmm.
And if we didn't, there would be an error somewhere. Where do you think the error would most likely be? Standard algorithm or area model?
Area model.
Mhm. Most errors occur in the second row of the standard algorithm. Okay, add them up. All right, that's the lesson today.